So next up, we have our final presentation from Alemohammad from Radiant Earth. So Jonathan, please push go.
Hi everyone, my name is Alemohammad. I'm the Chief Data Scientist and Executive Director with Radiant Earth Foundation. Today I'm going to talk about how we use a stack to create reproducible machine learning workflows, particularly on Radiant MLHub. If you consider a machine learning modeling cycle, you usually start with a set of training data, which in the case of supervised modeling contains a source data and a label data. You train a machine learning model, then you deploy that model and generate predictions over a new area, or you might use your test collection of data and evaluate the performance of the model. Using the metrics derived from this, you might go back to improve your training data in terms of representation and distribution, or use a different architecture and deploy and train another machine learning model. And this cycle continues until you come up with an acceptable level of accuracy for the model, and you go after then publishing your model. When we talk about reusability and reproducibility of these workflows, I mean, for example, you might pick an existing model, combine that with new labels and new source imagery, and train a new machine learning model on top of that. This might be a fine-tuning for a new geospatial location or a time period, and then deploy that to generate new predictions or inference. Or you might go after just reproducing the results of that existing model to see how it performs over your area of interest, for example, without any fine-tuning. To ensure the reusability and reproducibility workflows, we need to publish the ML models using an inclusive set of metadata and collections, and also enable search and query for those, in addition to the publication of the training data. And today I'm going to talk about a stack of STAC ML extensions, particularly the ML model extension that enables cataloging machine learning models, and the label extension, which is for publication and cataloging of geospatial training data sets. So the label extension, as you see in this table, which is the item properties, covers a set of properties that are applicable specifically for labeled data sets. This can include generic properties, classes that particularly are applied to categorical labeled data sets, a description, a type of label, and at this time, label extension supports both vector and raster type of labels, and other kind of optional properties here. This is an example of a stack label item for a training data set on MLHub. You can see we have a set of properties. We have label classes, for example. This is various types of crop types in this label, a description. The type of label in this case is a vector data set. We have assets which include the documentation, as well as the actual label.json, which is the polygons of the label data set. Then we have a geometry, and then we have a set of links, including the typical collection and parent link, as well as a source link. This is a special kind of link for the label extension, which links the label collection to a source collection. So when we talk about label data set, you usually generate a label on top of a source imagery or a generic input data. And a requirement in the label collection or the label extension is you need to link to the source collection. So in this case, we are, for example, linking to the stack item for the source imagery that was used to generate the labels here. This is a relationship between two stack collections, basically. And usually the query happens on the label collection, and when the user lands on a required or a preferred label item, then they can find the corresponding source item and start using that data. Then on the model extension, we have, again, various types of fields, the model type, the learning approach, the prediction type, architecture, and so on. And the goal has been how we can ensure that we have the right metadata that the user can reproduce this model or reuse it. Most of these properties are derived from a community conversation and a hackathon we have ran last year, and a continued conversation on GitHub and our Slack channel with various users and interested groups. So if you're interested, I would encourage you to join that conversation. This is, for example, a stack model item, a sample from an existing model on MLHub. You see in the links, for example, we have a Docker image that is for inferencing. So you can use that to run the model for inferencing. We have a relationship to the training data set in this case. So the model is trained on an existing data set, and that data set has a stack collection. We link it here, so there is this relationship again between the model and the training data set. We have the source data collection, the labels collection, and the actual data set. Then we have the assets, which in this case includes the model checkpoint. So the final model weights and the checkpoint from the training is included, as well as the Docker compose file, which is used for inferencing. On MLHub, we use both of these extensions, and we provide a large number of training data sets and models now that you can access either through the website or through our STAC API, which also has a Python client around it, and we can use it natively in Python to find and query existing data sets and models, or download them and use them. So I encourage you to check out mlhub.earth and check out the existing catalogs that we have. One final call is a community conversation around the STAC label extension. We know it's a growing use case for various groups who are working on the machine learning application, so we would like to have a kind of chat about this extension, how we can improve it, what are the use cases that it needs to support, and how it should basically evolve over the following year. So if you're interested, please join us this coming Friday at 11 a.m. Eastern Time, 3 p.m. UTC. The details will be a Zoom meeting that we'll post in our Slack channel. Please join MLHub Slack, join on Bitly, and we can share the basically details there. Come up with any use cases, any issues you have using label extension, or ideas in terms of how it should be improved. Thank you.
Great, thank you, Hamed. He's not online for questions, but I certainly want to talk to him about sharing some models. We have a model around our crop mask that I want to share, training data and a model, so I'll follow up with him. Thanks, Renee, for sharing the link on GitHub for that workshop on Friday. We are 2 minutes over time, but since there's no sessions afterwards, I'm happy to open up for a bit of a conversation with whoever's here. And if anybody has any questions, please put them on GitHub or through the GoToWebinar interface. I think you might be able to raise your hand. Is that right, Jonathan? And have your audio opened up too.
That's correct. Anybody that has a question live, they can raise their hand and I will unmute them.
Getting kind of late for everybody else. Maybe they're too tired to ask questions.
Yep. Well.
Oh. No, just more discussion on some of the other topics.
Yeah. So there's just a little bit of chat on GitHub. So look, we might, since we're just over time, I think we might as well leave it there. Thank you very much for coming along, and for those that watch the video later, thanks for paying attention. And thanks to Chris Holmes for putting this together. It's been really great. Cheers.